Hello, everyone. Today we are going to be talking about one of the most epic, monumental, and bombastic types of energy currently in our world, and one of the most harmful and deadly, too. But it's also helpful in some ways. That's right, we're going to be talking about nuclear energy. The word nuclear is associated with the nucleus of an atom, or the energy once the nucleus is split apart. This happens when a determined type of atom named uranium atom splits apart because of the neutrons that slam into the uranium atom, pressurizing the atom to break apart and release sufficient and copious amounts of energy, which is called fission. According to the Department of Energy, fission occurs when a neutron slams into a larger atom, forcing it to excite and split into smaller atoms. This fission is released alongside the formation of heat, radioactivity, and more neutrons once the uranium atom splits. In short, this is called nuclear fission. The term nucleus first originated in 1704, meaning kernel of a nut. Over time, the term nucleus had changed silently, which first started in 1844 when scientist Michael Faraday used it to describe the central point of an atom, and was not widely used at first. A key figure for understanding nuclear energy was Albert Einstein, one of the most influential scientists to this day, who wrote the famous equation energy equals to the mass of an object multiplied by the speed of light squared in 1905, which proved mass and energy and was extremely helpful for the study of nuclear energy. The first atomic usage of the word nucleus was used by physicist Ernest Rutherford in 1911 to 1912 in his atomic theory. Rutherford's theory, according to Britannica, is the model described the atom as a tiny, dense, positively charged core called a nucleus, in which nearly all the mass is concentrated, around which the light, negative constituents called electrons circulate at some distance, much like planets revolving around the sun. Nevertheless, the usage of the word nucleus in this context did not happen swiftly. Other physicists who contributed greatly to the study of nuclear energy were Enrico Fermi and James Chadwick. Now, you may be thinking, well, who discovered nuclear fission, the release of nuclear energy? Was it probably just another old white guy in history? Well, I'm happy to say that you are wrong. According to APS News, in December 1938, over Christmas vacation, physicist Lise Minter and chemist Otto Hahn made a startling discovery that would immediately revolutionize nuclear physics and lead to the atomic bomb. In December of 1938, physicist Lise Minter, alongside one of her peers and close friends, chemist Otto Hahn, found nuclear fission while Lise was finding research opportunities when she had just graduated from the University of Vienna. They did this by bombarding uranium and other elements with neutrons. According to APS News, she grew up in an intellectual family and studied physics at the University of Vienna, receiving a doctorate in 1906. As a woman, the only position available to her at the time in Vienna was as a school teacher, so she went to Berlin in 1907 in search of research opportunities.
She's got a point. She's an icon. She's a legend. And she is the moment. Now, come on now.
Okay, maybe Otto was also just another white guy in history, but He gets a free pass because teamwork makes the dream work, and he decided to study alongside a woman trying to find nuclear fission in the 1930s, a very sexist time period.
Oh, excuse me. My hand shakes so when I'm around you.
Oh, yes, it's time for another guessing game. How many times have nuclear weapons been used in warfare? 4 times, 5 times. How about just twice? In Hiroshima and Nagasaki in 1945 during World War II. According to UNODA, nuclear weapons have only been used twice in warfare, in the bombings of Hiroshima and Nagasaki in 1945. Yes, we're getting into the danger zone. No, seriously, this part is just dreadful. Hiroshima and Nagasaki were 2 Japanese cities that suffered a terrible nuclear attack sent by the United States. According to ICAN, by the end of 1945, the bombing had killed an estimate of 140,000 people in Hiroshima and a further 74,000 in Nagasaki. Many innocent civilians and other people who contributed to the war on August 6th and 9th lost their lives. Rest in peace to all the poor souls who died in the day of the bombings. You shall be missed.
It was so dark because of the smoke and dust being sucked up in the mushroom cloud and the ghostly procession. I say ghostly because they just didn't look like human beings. Their hair was just all standing up towards the sky. They were burned and blackened and swollen. Parts of the bodies were missing, and they were covered with blood, and clothes were tattered, and the flesh and skin hanging from their bones.
These bombs were so dangerous and deadly that they were never used again in military history. But we can't talk about nuclear weapons without talking about the Tsar Bomba, one of the most powerful and Herculean nuclear weapons ever tested on Earth. According to Wikipedia, the Tsar Bomba is the single most physically powerful device ever deployed on Earth, the most powerful nuclear bomb tested and the largest human-made explosion in history. The Tsar Bomba was tested at the height of the Cold War, a war between the Soviet Union and the United States that lasted from 1947 to 1991. On October 30th, 1961, the Tsar Bomba was dropped on a test site named Novaya Zemlya in the Arctic Ocean and was deployed by parachute so that the crew and the plane could have enough time to escape. It had a yield of 50 megatons, which is the equivalent of 50 million tons of TNT, and was more powerful than Hiroshima and Nagasaki combined. According to the National World War II Museum, the detonation was astronomically powerful, over 1,570 times more powerful, in fact, than the combined 2 bombs dropped on Hiroshima and Nagasaki. The Tsar Bomba's yield was 50 megatons. The bomb was catastrophic and dangerous, having a mushroom cloud 40 miles high, which is even higher than Mount Everest itself, and instantly causing environmental damage nearby. According to Nuclear Museum, the Tsar Bomba mushroom cloud was approximately 40 miles high, 7 times higher than Mount Everest. Thankfully, the bomb was never used for warfare and still holds the record for one of the biggest bombs ever tested to this day.
Oh my God!
Now, we know how impressive and grand the birth and adaptation of nuclear resources have been over the past centuries, with nuclear questions giving us new questions to solve in our big world and easier things to discover because of the new science we have learned over time. Sure, nuclear energy is dangerous, but it can only be found in safe and contained environments, unsusceptible to human reach. We've learned from our mistakes in the past, right? Right? Well, maybe a yes and nuclear energy does not play a part in the ecosystem the way photosynthesis does. Nevertheless, it can still greatly impact human ecosystems with its energy and power. An example could be
That
nuclear
sounds like a terrible
emissions.
thing, right? Like a polluting, unhealthy for the environment type of thing, right?
Well, quite the contrary. Nuclear power plants do not produce any greenhouse gas emissions whatsoever during operation and emit minimal air pollutants like sulfur dioxide. They are also compared with other renewable energy resources like solar power and wind power. And unlike renewable energy resources, nuclear power plants provide a consistent source of energy and do not have many problems with installation and manufacturing. According to Department of Energy, nuclear is a zero-emission clean energy source. It generates power through fission, which is the process of splitting uranium atoms to produce energy. The heat released by fission is used to create steam that spins turbines to generate electricity without the harmful byproducts emitted by fossil fuels. And NEI. In the U.S. alone, nuclear electricity prevents more than 471 million metric tons of carbon dioxide from entering our atmosphere every year. Nuclear facilities also require the least amount of land to generate electricity compared to other energy sources. It is reliable and stable. And lastly, IAEA. Nuclear power plants produce some of the most competitively priced low-carbon energy. Well, that sounds amazing, right? Low emissions and practically free installation? Sign me in. However, we do have to remember that nuclear power plants are still nuclear energy, and we will have to deal with things such as radioactive waste management, which is a very intricate and unsafe. According to the UK radioactive waste inventory, includes planning and preparation, waste treatment, packaging, storage, and disposal. This may all sound simple, but radioactive waste management is a complex process aimed at keeping humans and other living beings safe from the hazards of damaging your DNA and cancer. And the management of radioactive material is extremely important because of this. According to the US EPA, radioactive waste is hazardous because it contains or emits radioactive particles, which, if not properly managed, can be a risk to human health and the environment. We also must consider the risk of accidents despite the extremely strict rules in radioactive waste management power plants, like the Chernobyl accident in 1986, where there was a power surge and explosion in the nuclear power plant. According to the World Nuclear Association, the accident destroyed the Chernobyl 4 reactor, killing 30 operators and firemen within 3 months and several further deaths later. In conclusion, these are some of the many examples, progressive moments, and historical moments of nuclear energy. Nuclear energy has been with us for centuries. We have been dedicated to learning and understanding more about it, which helps us evaluate more theories of several types of energy and find the truth of some traits about it. Nuclear energy is a part of many diverse types of science and education because of its subject of study, which was one of the most important and innovative types of study when we found nuclear fission in 1938. Without energy, there is no life, so we must strive to learn more about energy, such as nuclear energy. We may have more questions than answers when we find out more about energy, but that's just what science is. Finding an answer and searching for more, which is what makes science so interesting. You want to learn more about it. And as always, thanks for watching.